Welcome back to Computer Vision. I hope it's welcome back, because if you're jumping in now, you missed some really good jokes in some of the better lectures. This one's okay, actually. All right. Anyway, today we're going to talk about extrinsic camera calibration. We'll define what that means in a minute. We took a little hiatus to talk about stereo, so you guys could get working on your stereo. And stereo was our first look at multi-view geometry and multi-view cameras. And we talked about how, in order to do real depth reconstruction, we have to understand the geometry of what's going on between the cameras. And that's what we're going to start talking about today. So before the stereo thing, the stereo sections, we introduced projection, perspective projection. And here was the model that we used. In particular, we had a system where we had a center of projection that was located at the origin of a three-dimensional camera system. And then we derived from similar triangles the location on the image of the point projected down onto the image plane. And then in order to figure out where the point was going to land on the image, we just eliminated that last coordinate. Now, we said that this was a bit of an issue because this division by z was nonlinear. And because we had to pull out the particular z, it wasn't a constant z, it was the particular z. So we introduced this notion of homogeneous coordinates. And the homogeneous coordinates essentially added another component to the vector. And if it was 2D, it became a 3-long vector. 3D became 4. And the idea was that we were going to be able to convert from homogeneous to non-homogeneous when we needed it. But before we did that, all of our operations could be done through matrix multiplication, which, by the way, made homogeneous coordinates, the whole thing, invariant under scale. I could scale a coordinate, homogeneous coordinate by anything, and when I did the normalization, divide by w here, it would go away. And one of the reasons we did this is we said that perspective projection could now be done as a matrix multiplication. So here I've written 1, 1, and here we've got 1 over f. And by the way, just to make life easier, I'm using the absolute value of z, so we don't have to worry about z being positive or negative. So when I do the multiplication, I get this homogeneous coordinate, and when I want to normalize and go to unhomogeneous, I get the uv by dividing it out. But in all of this discussion about projection, we have the notion of a camera's coordinate system. By the way, I'm going to go like this, and it's not some like weird curse in Georgia. It's a coordinate system, 1, 2, 3. Okay, so we have an origin and a coordinate system. And we said that we put the center of projection at the camera's coordinate system, and with the z-axis, the optic axis, going down the z-axis. So to do geometric reasoning about the world, we need to be able to relate the coordinate system of the, I guess I'm going to have to do this. We have to relate the coordinate system of the world to the coordinate system of the camera. And in fact, today, what we'll do is the coordinate system from the world to the camera, and then today, I don't know when you're going to watch it, next month, the next lesson will be the coordinate system from the camera 3D coordinate system to the image.